Hi, I'm David. Welcome to this session, AI in SRE, Unlocking Prometheus Insights with Natural Language. In this session, I'll be discussing a project I worked on that tried to answer the question, is it possible to chat with your monitoring metrics? I'm excited to share what I've learned, and I ask that you pay attention as we go through it. So the talk today is divided into 5 sections. We do like a general introduction, we look at the approach by which the tool was built. The tool itself is called Prometheus, so we'll spend some time reviewing the tool itself. Lastly, we'll discuss the result and then a closing out section. Okay, moving straight on. So the first section, introduction, was the problem, what our solution. So as SREs, we understand the importance of speed when it comes to incidents. And if you have a tool that allows you to be able to chat with your metrics, it can speed up your incident response significantly. For me, I think there are two ways to think about it. The first is that it reduces cognitive load while responding to an incident. We already know that there is pressure to restore user experience as fast as possible. So having a tool that helps you write prompt cure without you having to think about it reduces the cognitive load required with responding to incidents. On the other side as well, you're able to get quick insights without having to go through multiple dashboards, which is another way in which it can lead to faster incident response. The other usefulness of having a tool like this is that it makes data accessible to everybody. Traditionally, to expose data from your Prometheus instances, you will build dashboards for people that are not capable of writing like their own prompt queries. So you would build dashboard on things like Grafana, which they can go. But of course, that means for each type of data or each question that they have, you need to create a dashboard which they can go and see. However, if they have a tool that they can basically ask questions, then you don't need to keep coming up with a new dashboard each time that there's a new query or a new question. They can basically just interact with the tool and get instant answers back. The other advantage of having a tool like this is that it eases the learning curve for Prometheus. Starting up, it's easy to write simple Prometheus queries, as you need to write more complicated queries. Things can get a bit harder, especially if you're just learning the language. So having something like a tool like this that can essentially cooperate with you like co-pilots when you're trying to write prompt clearly is good, because it helps you ease the learning curve, especially if you're getting started. And then I think one of the major motivations for me to actually work on the project is I see a lot of projects in the data space that allows you to be able to chat with your data. So tell AI ask questions about your database and things like that. So I started wondering, is it possible to do the same thing for metrics, especially in the monitoring sense? So that's like the motivation in trying to solve the problem and answering the question, is it possible to chat with your monitoring metrics? So the solution that I came up with that is discussed in this project works this way. So the flow is we're building a tool that allows users to essentially ask questions in natural language, and then the AI agent takes the natural language and generates a corresponding prompt QL query. The prompt QL query is then run on Prometheus to get the actual result back from Prometheus. But then that result, before it gets back to the user, is converted back into natural language. So the flow is that it starts with natural language and it ends with natural language. The user asks questions in natural language, and then they get a result presented back to them in natural language. So the second section of the talk talks about the approach. So at this point, we'll dive deep into how we implemented it, the architecture, and then we review a couple of the key components of the architecture. So this diagram shows our architecture for the system. So on the far left side of it, we have the front end, which is how you interact with the system. So it's either you're interacting with the tool via a web app or a Slack app, basically, which allows you to enter your user query, and then that user query gets sent to a backend. The backend has a REST API that makes it easy for the front end to interact and send questions down to it. As part of the backend as well, we have the AI agent. The AI agent basically handles the coordination with the LLM. So when the user query comes, it basically sends the request to the LLM, And then the LLM as well uses what is called tools calling or function calling to be able to talk to Prometheus. So on the Prometheus aspect, we need to be able to fetch metadata from Prometheus and run queries from Prometheus as well. As we go later into the talk, we'll talk more about the metadata such that you have better understanding of what that entails. But essentially, this gives an high-level overview of what happens when you're trying to answer questions. So the flow is the request comes in, let's say, from the web app, goes to the backend. The backend takes the question, sends it to the AI agent. The AI agent takes the question, sends it to the LLM. So the user query together with the metadata. So the metadata in this case is, you can think of it like the schema of your data. So it basically just contains information regarding what kind of metrics are available in your Prometheus instance and the descriptions for them. So you send that together with the user query to the LLM. The LLM then thinks about a prompt QL that would be able to answer that question correctly. Then when it has the prompt QL, it sends it back to the AI agent, which then runs that query on Prometheus to get the actual result. And then once the result comes back from Prometheus, it's passed back to the LLM such that the LLM can interpret the result in natural language, and then the result goes all the way back to the front end for the user to see. So that's what the overview of the system looks like. We'll be looking at a couple of tools that allows, or the key components of the architecture as well. So the first one is Prometheus. Again, if you're not familiar with Prometheus, I won't spend too much time diving into it, but you can check it out. What you need to know is that it's a time series data store for metrics, and typically metrics stored in Prometheus have this format where you have the metrics name and then you have the label. So in this case, the labels are method and handler, and then they have the corresponding value of posts and messages. So this is an entry of Prometheus, of a metric in Prometheus. So this metric is then scraped by Prometheus quite often based on whatever scraping interval you have. As the time series data is going to record the time that it was scraped and then the value at that point in time. And that's how this Prometheus pathway works. So part of the things that make this architecture works is that Prometheus has this metadata API that allows you to get, again, as I described earlier, like a schema of your data in the Prometheus instance. So what that entails is that it shows you the list of all the metrics that are available inside of your Prometheus instance. So in our case, for example, you can see advisor, this device usage, total, CPU load average, CPU system cycles. These are examples of metrics that have been scraped by Prometheus and is available in the Prometheus instance. So that means you can write queries or ask questions regarding these metrics. But not only is the name returned, it also returns information, helpful information about them, which is the type of the metric itself. Based on the type of the metric, again, it depends, the kind of operations that you can perform on a metric depends on the type of the metric, right? So that's something to take up. That needs to be taken into account while writing your prompt QL. And then the help bit also gives information, additional information regarding each type of metric, which allows you to be able to interpret the metric correctly. Additionally, sometimes you can also add information about the labels. So for example, for this HTTP request total, the description can be something like, oh, it lets you know the number of HTTP requests that has happened within a time period. And it has the following labels like method and handler. So this metadata is the additional bit that is sent as context along with the user query itself to the LLM. So that's the first major component. The second major component, as we explained, is the LLM, and then it makes use of a technique called tools calling or function calling, which is basically it extends the LLM such that it's able to interact with the environment that is outside of the LLMs itself using tools. And to make that happen, we have built two tools in our example. So we have the Query Prometheus tool, which basically allows the LLM to execute Prometheus query on an instance and get a response back before returning a response back to the user. The other tool also allows the LLM to be able to query Prometheus for the metadata information, similar to the metadata information shown in the previous page here. So basically, the first tool allows Prometheus to be able to run a degenerated prompt query and get responses back from Prometheus, while the second tool allows Prometheus to be able to fetch metadata results from Prometheus itself, metadata regarding the metrics available. So that's the two major components in our architecture. So moving on to the third part, which is we are looking at the tool that was built. So the tool itself is called prompt chat, and basically we'll be exploring the tool from 2 points of view. So based on the data inside of the Prometheus instance, we've classified it into 2 examples. The first one uses data from Node Exporter, and then the second example of prompt chats uses data from custom exporter to Prometheus. So both of them you're chatting with Prometheus. So what's just different is the source of data in the Prometheus instance, and which basically affects the type of queries that you can, or questions you can ask, and the type of queries that will be generated as well. A little bit more about the Node Exporter. So the Node Exporter is essentially like a plugin that you can run on a VM. You can run it on a single VM. You can run it on your local machine, for example. Pretty much any like machine, VM, node, you can run it. So what it does is it exposes system metrics to Prometheus such that Prometheus can script them at intervals. So for example, things like the CPU seconds, the available storage, memory utilization, network traffic, all of that can be exposed by the Node Exporter. So they are standard system metrics and you don't need to configure anything. The Node Exporter basically just makes those available, and then those data can be injected into Prometheus. So these are samples of some of the metrics that are available. So as you can see, node CPU seconds total, the system available, file system available in bytes. And then this is on the number of network requests in bytes that have been received, as well the average network traffic in bytes over the last minute. So examples of the metrics, and then some of the queries, so you can see using like rates to get like averages over a time period of time. So this is what a Prometheus query looks like as well. So moving on. So this is showing the actual tool called prompt chat and the responses that was generated by the system when it was asked certain questions. So in this example, the prompt chat is connected to the Prometheus instance that has data from a node exporter. So the information available, the kind of questions you can ask is based on the kind of metrics that is exported by the node exporter. So in this case, we can see 4 exchanges or 5 questions in total actually. So the first talks about CPU utilization. So this is the question. So in black here, you have the user question itself, while in white is the response from the prompt chat AI system itself. So it looks first asking about the current CPU utilization on the node. We get this. He asks about the battery percentage on the node, more around the information always running on the node. So I did run this particular example on my laptop using the macOS node exporter. So you can see it gets that the node is running macOS, the disk space that is available across all the instances of the nodes, and then finally the memory utilization of the node shown as well. All right, so we'll look at in follow-up, we'll look at later, we'd actually see from the backend what queries are generated for these examples and what they look like. The second Prometheus instance I'll be using is thanks to our friends at promlabs.com. So they have this Prometheus instance that is publicly accessible. So it's from the team that wrote Prometheus, and they make it available so that you can use it to experiment, to learn, and interact with Prometheus. On that Prometheus instance, we have some custom metrics. So if you look at the first set of metrics that was exposed in our first example using the node exporter, those metrics are system metrics, meaning that they are metrics from regarding the machine itself. But more often than not, when we are trying to set up monitoring, we want to collect metrics about the state of our service or the application we are running as well. So in those cases, you would come up with like your own custom metrics describing the different states or events in your service. So the Prometheus on PromLab, the demo Prometheus instance on PromLab. So it runs a service called the demo service. And then the demo service exposes the following custom metrics, which is what we're basing the next set of questions and interactions with prompt chat on. So a couple of interesting ones that you see is one is that they are batch jobs. So you can essentially ask questions around success rate of batch jobs that was done by the demo service. You can see questions around the HTTP request duration as well. Another interesting one is that the service itself has a matrix that lets you know whether today is an holiday or not. So it's basically called demo is holiday. And from the help information. So again, if you look at the metadata information, this is GUI not from the API, but basically it's going to be similar to the metadata API response showed earlier, where you can see the name of the metric, the type of it, which is in this case for his holiday, we can see the type is set as gauge, and then the description helper text is that when the value returned is 1, it means that the current day is an holiday, and when the value returned is 0, it means that the current day is an holiday. So these are examples of custom metrics that has been made available by the demo service on this instance. So all of these metrics has been scripted and is available inside of the Prometheus instance. So that means we can connect our prompt chat tool to this Prometheus instance and ask its questions and let the AI generate the corresponding queries and show us answers. So let's see how that looks like. So in the next chat, here we can see is the prompt chat tool is connected to the Prom Labs Prometheus instance, and the first question here is today an holiday. So the AI system responds that based on metrics that I was able to find from demo service 2, it reports that today is an holiday. Again, just in the next couple of slides, we'll be looking at the actual query and how we got to this answer. But basically, this just shows an overview of what the interaction from the web interface looks like. The second question we ask is how many items have been shipped today. So if we go back up, we'll see that there is a custom metric exposed called items shipped total, which is a counter that keeps track of the number of items that have been shipped. So making use of this, we expect that the AI will make use of this counter to be able to answer the question of how many items have been shipped today. And then lastly, there's a third question here where we are trying to ask questions around the demo API and if it's taking longer than usual. Unfortunately, we realize, as you can see from the screenshot, the AI system response that there is no data found. So we'll look at that and try to figure out, okay, why did that happen as well? Behind the scenes, as promised, so this is basically the logs from the backend system letting us know exactly what transpired. So in the case of the first example message, the user query is a today an holiday. Then the AI agents generated this corresponding prompt QL query, which is demo is holiday, right? And then this generated prompt QL was run by the AI agent using function calling on the Prometheus instance, and Prometheus returned this response. So if you pay attention to this, you will see the instance name is demo service 2, which is why the response talks about demo service 2. But the most important stuff to pay attention to is the value here. So you see the value here is 1. Because this value is 1, that means based on the helper information that we're able to get from the metadata, we know that 1 means holiday. So you can see in this example, the AI agent is able to both write the right corresponding query based on the metadata, but also based on the helper information provided in the metadata, it's able to interpret that 1 means that today is an holiday. And as such, based on that interpretation, is able to reply the user query back in natural language saying, yes, based on the data that you can see from demo service 2, the value is 1, that means that today is an holiday. So this is essentially what's going on behind the scene in the case of the first question. In the case of the second question, this is a way more interesting. So we asked about how many items have been shipped today. This is the user query. Again, the generated from QL. As expected, it makes use of the metrics demo item shipped total. So it sets the time period to 1 day. This is right. And then it looks at the increase over the period of 1 day. So this is generated from QL query, which makes sense. So again, using tools calling, that this query is executed against the Prometheus instance, and Prometheus returns this result back to the AI agent. So now the AI needs to figure out how to return this in natural language. And this, I think this is interesting. Particularly, this is a particularly interesting example because we would see that the demo service actually runs 3 copies of it. So as you can see here, there are 3 instances of the demo service. There is demo service 0, which is the first instance. There is demo service 1, which is the second instance here. And then there is demo service 2, which is the third instance. So for each of these instances, they have been processing orders through the day, and each of them maintain a count of the number of orders that they've processed. So if you look at the demo service 0, it returns around 455,000 orders had been processed by demo service 1. And then if you look at demo service 0 rather has processed 455,000. If you look at demo service 1, the value for it is 453,000. And then if you look at demo service 2, the value processed so far in the day is 453,000, close to 454,000 as well. Now, the LLM does something interesting because it gets this result back. It is intelligent enough to know that the value it's interested in is an aggregation of the value across each of these instances and also applying the right grouping. So it was able to figure out that it needs to sum the value from demo service 0, demo service 1, and demo service 2. So if you look at this value, so you can do it later, but I've confirmed it. If you sum this value returned for demo service 1 plus the value summed here, demo service 1, this is the value returned from demo service 2 plus value returned from demo service 1 plus the value returned from demo service 0, you're going to get the total value here. So the LLM was actually able to figure out the right aggregation for the list of data that was returned in the result, sum it appropriately, and give the right number back in natural language back to the user. So this is another example that shows how it really shines to get instant, and this happens like instantly. So again, you're able to get instant, insightful data while making use of the tool. Now looking at the third example, in the case which we are unable to get any response back. So again, this is the user request or the user query. The user asks a request to the demo API taking longer than usual. Then the AI agent generated this query. Now the query in terms of the syntax is valid. There's nothing wrong with it. It never returns an empty data set, and that's not because there is no data available for the demo API, but how the LLM has interpreted the question and it has tried to go about writing the query is incorrect, and as such, we get an empty data back. Although it's a valid PromQL query, it doesn't answer the question that the user has asked and doesn't give us any response back. So that's one of the limitations that we've discovered here. But again, looking at it, is there a way to get around this? So we'll discuss that in the next session. So in the next example, or as you can see here, so this is the prompt chat application itself. When you come here, you're able to modify the LLM configurations where you can set what provider you want to use, what model you want to use as well. So in this case scenario, it's currently all the questions that we've asked so far. We are using Google's Gemini model, and then we are using the Google Gemini 1.5 Flash, which is their fast free model. So that's what we have used so far to answer all our questions. But we see that Gemini 1.5 in this example was unable to generate a correct PromQL query for us. So then by changing the model type to the thinking model, so if you check here, based on the configuration prompt chat, so I've flipped the model to use the thinking model provided by Google, which is the Gemini 2.0 Flash thinking model instead. So by making use of this model and asking exactly the same question, we're able to see that now, if you look at this example, the AI agent is actually able to answer the question correctly. So we'll look at the backend and see what has changed. But in this case scenario, you basically ask the same question based on the newer thinking model. He was able to provide this insight and say, oh, you can see that the /API/path seems to have a lot of 500 errors. And as such, the latency is also significantly higher than the other paths as well, which suggests that the path has an issue. So as an SRE, you can imagine how insightful such an insight like this is when you are currently trying to debug an incident and you're trying to figure out what's going on. Maybe you get like a latency alert, or basically users start complaining that your system is slow. You can basically just fire up the tool, ask, and get insightful information like this. Now going back to the backend, we can see especially what happened. So from the backend there, you would see pretty much the same thing, the same user request. But if you pay attention here to look at the generated PromQL, that this generated a different PromQL that is more appropriate, is considering the rate now, and also based on the type of the data is able to use the histogram counter, and as such, he was able to actually generate meaningful results this time around. So this is the full response is way much longer than this because there are a lot of metrics that match this, but essentially based on all of this, you're able to get for each part, you can get the status and then you can get the value. So based on that, the LLM was able to then go over all of these results, similar to the first one. It was able to group them appropriately and then also identify the outlier in the list after the grouping, and as such, he was able to figure out that compared to the other guys, you can see that the /API/bar has 500 errors more, and then the overall latency as well is higher compared to the rest of the parts. So this shows basically how by changing the LLM model that is using a more powerful LLM model, you're able to get a better result for queries that, or in cases where the simpler models were unable to write valid queries and compare the results that was returned. So moving on to the fourth section, where we basically just discuss a summary of everything that we have learned from interacting with prompt chat. So this is the first part, basically talks about what are the lessons that we have learned, right? You would see throughout from the architecture and the rest of the presentation, there's not at any point did we attempt to retrain any of the models or do any sort of fine tuning. So what that lets us know is that state-of-the-art LLM models today are actually capable of writing PromQL queries on their own. The other thing to note as well is that the only change we had to do actually was to use one-shot prompting, which is basically adding an example to ensure that the output that we get from the LLM is formatted exactly how we want it. And that's important because you initially while running projects, we're getting into issues where the response coming from the LLM model, it would add additional like characters or tokens to it. And then once you pass it to the Prometheus instance, it won't be valid. It would no longer be valid PromQL, and that will lead to like crashes or issues because Prometheus cannot interpret the query. But after using one-shot prompting, where we are basically able to show the LLM exactly the format of the response, he started returning exactly just the PromQL required without any additional characters or tokens around it, and that way basically we're able to avoid having to manually try to extract out the PromQL out of the LLM response. Based on the last example that you see as well, would realize that obviously the thinking models are better when it comes to trying to write complicated PromQL. So the lighter models work for most cases as well. But when you want to ask more complicated questions, it's more useful the more powerful the models are, and the more time they spend thinking, the better the prompt cure that they write as well. So we've seen that again in the last example. So some of the limitations that we also observed in the course of working on this project is that, as you would see, the majority of being able to pull this off depends on the quality of documentation that you add to your metadata. So Prometheus would always have the metadata API available, and it will tell you, okay, these are the metrics that I have, and then these are the types of those metrics. But if you don't add any helper information to interpret, for example, if you look at the case of when we had the demo service, is today holiday that metric. If the documentation does not contain information saying, hey, 1 means today is holiday, 0 means today is an holiday, then there would have not been any way for Prometheus, for the LLM to interpret correctly the Prometheus response that it got. The other challenging bit as well is, even for cases where you have the documentation or the helper text included as part of the documentation, most of the time the labels are missing. Labels in this case are like, if you compare it to traditional databases, so maybe like the colons or the fields, because you don't know what fields or what labels are available in that particular Prometheus matrix, it makes it harder for the LLM to be able to write correct queries, especially when you need to filter by things like the actual label value. So that's one of the things. But again, that can easily be solved by essentially going over the documentation and adding as much useful information there as possible. The other limitation noticed as well is that sometimes you might have inconsistency in the results that you get because the queries generated differ slightly. And that's important because if you frame your question slightly differently, then the LLM can interpret it differently and generate a corresponding different query, which would then give you a different result. But that can be eliminated by having more exact descriptions in your question. So, for example, if you're saying A, is there any endpoint currently showing 500? But if you don't put a time frame, the first time maybe you might do it over an hour or like maybe 5 minutes or maybe 1 minute. But if, for example, you ask specifically with a time frame, then the generated prompt query by the AI agent would contain that exact time frame, and then you get the same response back. That's another limitation. But again, how that can be improved upon is basically just putting the more exact your question is, the better the answers that you get. So in terms of the feature improvement, so better support for complex queries. So this better support includes things like being able to undo more complicated queries, being able to even supply right now all the answers are coming back in text, in natural language. But of course, it might be useful to maybe have a graph to look at from time to time. So for more complicated queries, for example, it might be useful to return both the natural language, but also some form of visualization for it. Also, right now, the project is limited to just Prometheus. So that's the only metric source that it works with. So in terms of next steps, you're looking at expanding the project such that it supports more than just Prometheus as a source. And then lastly, I think another interesting improvement would be around the system being able to learn from user interaction. So imagine you ask a question and maybe, for example, you didn't use the right labels, or it doesn't know the labels that are available for that particular metric. So it asks that, okay, I can answer this, right? And then you provide those labels. Now it would be useful if right now there is no memory in the system, so it actually doesn't store that information. So an extension would be such that next time you actually don't have to go back and supply the same labels back to the system for it to answer correctly. So that's like a future improvement when it comes to it's actually learning from user interaction. Another way that can go is when queries, for example, let's say the queries are wrong or like the wrong metrics was used and you correct it again. All those kind of interactions can be stored such that it's used as context next time it's trying to answer questions. and as such, you can make use of that, and then the system gets better over time because it's learning from user interactions. So lastly, how can you contribute and join? The source code is available on our GitHub profile. So it's open, the project is open source. So if you go to Nestle HQ on GitHub, you see the source code for the prompt chat app. So issues, PRs are welcomed to as a means of contributing to the project. Also, the web interface that I was playing with or that was shown in the slides is available at promptchat.nespa.co. So you can basically visit that. It's available. You don't need like any authentication payment or anything. The only issues might be because it's using my own personal API keys, so there are limits to the number of like daily requests. So sometimes maybe if a lot of people have been playing around with it earlier in the day, you might not be able to get any responses back from the API. It would tell you that the LLM credits is exhausted. But yeah, but you can clone the project locally, put your own API keys and run it if you want to. But if you want to use the web interface, you can visit promptchat.nesla.co as well, and you would be able to interact with it. So that's it. That's it from me. So thank you very much for listening to this session. I hope you've learned a lot and you have a better understanding as regards how to implement something like this. And yes, the answer to the question is it is possible to chat with your monitoring metrics. And I do hope you enjoy the rest of the conference. Bye. Thank you.